Hey folks, Ms. Gosling here. In this video, we are going to be discussing electric power. Now, when we talk about electric power, we are going to be talking about the power either dissipated across a resistor or generated by a voltage source. So let's go ahead and start by breaking down our equation. So in our equation, we have our first variable P, which of course stands for power, which we're going to measure in watts. We also have our symbols for current, measured in amps, and finally our symbol for voltage, measured in volts. So here's going to be our equation for electric power. Let's go ahead and go through a video so that you guys are able to see how we can use electric power to solve problems. And what we're going to do is we're going to figure out the amount of current, or the amount of power generated by this circuit, which has a current of 0.5 amps flowing through it. So let's start by listing out our givens. We know that our voltage is 50 volts, and our current is half an amp. So I is 0.5 amps. And we are trying to figure out our unknown, which is, of course, the power. So P equals question mark. And to do this, we're going to use our power equation. So P is equal to current times voltage. This is nice because we don't have to do anything to shift around the variables in our equation before we go to our substitute and solve step. So we're going to say that our power P is equal to, again, our current 0.5 times our voltage of 50, which gives us a power of 25 watts. However, we don't always know our current and our voltage. For example, say we had a problem where we knew what our current was and we knew what our resistance was, but our voltage hadn't been solved for. What you could do is solve for your voltage and then use that to solve for power. However, a simpler way to do that would be to plug in this side of our equation for voltage. So what that would give me is that my power is equal to my current times, again, my voltage, but instead of V, I can say V is equal to IR. So what that gives me is that the power in my circuit is equal to I squared times R. And you can do this for any combination of two variables. So let's go ahead and try out that. And we're going to figure out the power generated by our circuit below. And we're going to start by, again, as always, listing out our givens. We know our voltage is 10 volts. And we know that our resistance is 20 ohms. And we are, of course, trying to find power. And so we're going to say P equals question mark. And what's going to change from that first problem is in my equation step, I'm going to write down P equals IV, but I'm also going to go ahead and write down V equals IR. And what I don't know here is, as you can see, I. So let's go ahead and use Ohm's law to solve for I. When we do that, we get that our current is equal to our voltage divided by our resistance. And we can plug that into our equation here instead of I. So what we get is that P is equal to V over R times V, or P is equal to our voltage squared divided by our resistance. So I'm going to go ahead and move on to my substitute and solve step. So P is equal to V squared over R, which is, of course, going to give me 10 squared divided by 20, or 100 divided by 20, or 5 watts. So there you have it, guys. You have now seen a straightforward power problem and a slightly more complex power problem where you have to use Ohm's law to figure out your missing piece. So now it's your turn. Go ahead and give it a try. Happy solving!